Hey everyone, it's Alice here from Top Mark Science, and today we're going to be looking at indicators. Throughout this video, we'll be exploring what an indicator is, examples of indicators, and the outcomes provided by different indicators. Let's get started. When you think of the word indicator, what first comes to your mind? Are you like me and thought of a car indicator? But in addition to car indicators, there are many others out there around us that we can use for a variety of reasons. Indicators in general are objects or substances that help us determine more specific information on the state or level of something. In the case of a car's indicator then, it flashes repeatedly on one side, and this tells other drivers more information about the direction the driver intends to move, whether it be left or right. The indicators might tell us other things, like the level of something. For example, certain organisms, called indicator species, indicate what is happening in their environment. In certain waters, the presence of some species of shrimp indicate moderate levels of water pollution, whereas no species present at high levels of depth indicate high levels of water pollution. But today we'll be looking at chemical indicators, which change colour depending on the type of substance they are in, telling us more information about that substance. Substances we'd be interested in knowing about might be acids. Acids are liquids that release hydrogen ions when dissolved in water. You can find strong acids in your body or weaker acids in your home. Some acids can be consumed, but these acids taste sour. In contrast, we have bases. Bases neutralise acids. In other words, they cancel them out to make them less acidic. And some bases dissolve in water. They are soluble to form a substance called an alkali. Alkalis are generally soapy textures and react well with oils and fats, so work well for cleaning purposes, like in toothpastes, or for stronger requirements, like bleach. Despite having their differences in uses and properties though, acids, alkalis and bases all have something in common. Caution must be taken when using them in the science lab. It's common for people to think that acids are dangerous and alkalis are not. This is just not the case. In certain concentrations and levels, all three have the potential to be irritants, or burn and destroy living tissue, or even react with metals, so they may be corrosive. You must take care when dealing with acids, alkalis, and bases. Pause the video here and use the statements 1 to 12 in the orange box to fill the Venn diagram to compare acids, alkalis, and bases. Remember, any overlapping segments indicate similarities. The middle would be a common statement for all three, and any differences should be listed in the individual areas. An example has been started for you, and if you finish, try the challenge. Let's go through some answers then. Get ready to annotate your work as we go. So number 1 states dissolve in water, which is applicable to both acids and alkalis, but not for bases. Not all bases are soluble and dissolve in water, so number 2 can be placed separately. Hydrochloric acid is an example of an acid. Hint is in the name, which is handy. Copper oxide is an example of a base. Notice the lack of the word hydro, so no water. Alkalis have a soapy feel. Acids taste sour. And you should take care when using all three of these, so number 7 can go in the segment that overlaps all three sections. Both acids and alkalis can neutralise acids. Acids release hydrogen ions when in water. Vinegar is an example of an acid. Sodium hydroxide is an alkali. And both acids and alkalis are corrosive when concentrated. Nice work, guys, for giving this a go. Now on to the challenge, to list ways to be safe using these substances in the lab. The list continues, but some key ones might include wearing goggles, standing when using to reduce spillage onto skin, securing lids when you're done with them, and limiting the volume and concentration of each. Now with potential hazards, it's hard to taste acids and feel the soapy textures of alkalis, which is where indicators come in handy. Indicators, when added to substances, might change the colour of the substance to tell us whether it's an acid or an alkali. One example of an indicator might be in your fridge at home, red cabbage, which can be chopped up and added to hot water to make a dark blue liquid, and this is your red cabbage juice indicator. You can extract this red cabbage indicator using a pipette and add it to a substance and watch it change colour. When using red cabbage indicator, reddish pink indicates it's an acid, and a yellowish colour indicates an alkali, and everything else in between will also have a colour too, which can be noted with a number. More on this in the next video of the pH scale. Pause the video here and match the substances listed below to the flask that you might think it could be. If you finish, try the challenge. Let's see what you thought. It doesn't matter if anything is incorrect. Feel free to annotate your work as we go though. Hydrochloric is acid, so this will be down towards the red. Bleach is alkali, so we'll be up at yellow. Water is neither acid or alkali. It's in the middle, which we refer to as water. Therefore, it would not change colour and the red cabbage juice would keep its dark blue colour. Baking soda is slightly alkali, so would be somewhere between water and bleach. Whereas lemon juice is an acid, but not as acidic as hydrochloric acid, so it sits somewhere between water and hydrochloric acid. And for the challenge, how might other indicators differ, is that they actually show various colours, which we'll look at now in the next section. Litmus paper is a commonly used indicator in the lab. You can get red strips of paper and blue strips of paper. These can be dipped into an unknown substance to determine whether it's an acid or an alkali. If you dip a red strip of litmus paper into an unknown substance, and when removed it stays red, that tells us it's an acid. However, if the dipped portion turns blue, it's an alkali. On the other hand, if you dip blue litmus paper and it stays blue, this means it's an alkali. Or if it turns red, it's an acid. Pause the video here and have a go at a couple of these tasks to practice our knowledge on using litmus paper. You can always re-watch that part of the video if you need a reminder. And if you finish, try the challenge. Time to go through the answers then, guys. Marking pens ready. When red litmus paper stays red, the substance is an acid. When blue litmus paper is dipped into acid, it turns red. Alkalis make red litmus paper turn blue, and blue litmus paper stay blue. Moving on to task 2 then, which applies knowledge of certain substances to their properties using litmus paper. Vinegar is acidic, which means red paper stays red but turns blue paper red. Whereas bleach is alkali, so makes red paper turn blue and blue paper stays blue. Baking soda is also alkali, so does the same as bleach. Lemon juice is acid, along with hydrochloric acid. And water is neither, and so does not change the colour of red litmus paper, it stays red. And blue paper stays blue. This links into limitations of using litmus paper in our challenge, because litmus paper not only tells us whether something is acid or alkali, but not how strong an acid or alkali is. If you also look at the results for water, it gives the same results for if it was an acid on red or alkali on blue, which gives false indication of the type of substance. So we need more information from another type of indicator. This is where universal indicator comes in handy. It's widely used in many science labs to determine the properties of substances. It's usually found in a small bottle, is green in colour, and is extracted using a small pipette. and can produce a wide array of changing colours in smooth transitions, like a rainbow, like red cabbage, which also produces different colours as we saw. Pause the video here to spot any similarities or differences between the colours of acids and alkalis of universal indicator and red cabbage indicator. Let's go through some answers here then. Chances are you might have found more than me. Write your ideas in the comments if you do think of any that I haven't. So firstly, both scales show red for acid. This is a similarity. However, orange is more acid for universal indicator, but alkali for red cabbage. Purple shows more acidic on red cabbage, but alkali for universal. Blue is more neutral in red cabbage, but alkali in universal. And finally, green is more neutral for universal, but alkali for red cabbage. You'll never need to remember which colours are different for which substance. However, it is good to know that not any particular colour means acid or alkali, as it is dependent on the type of indicator you have used. Time to finish off with our end of video quiz. Are you ready? Question 1. A substance that helps us identify if something is acid or alkali is called an indicator. Good start. Question 2. Name the missing type of indicator. Universal, cabbage, and litmus paper. Good job. Question 3. What happens to the colour of red litmus paper when it's placed in an alkali? It turns blue. True or false? Bases that dissolve in water are called alkalis. This is true. And final question 5. Alkalis are soapy. Acids taste sour. Pause the video here to rate your progress of your knowledge on chemical indicators since the beginning of this video. It might help you plan some revision and additional practice later. Thank you so much for watching this video, guys. If you enjoyed it and would like to see more from Top Mark Science, you can like this video and subscribe to my channel. And you can now find us on Facebook for additional resources, teaching and study tips, and general updates. Thanks for coming, and I'll see you later.